Hi, Megan here. Today I'm going to be troubleshooting um, one of the zones on my furnace. So this is a hydronic 4-zone forced hot water system. So there's a boiler here, there's a electric pump, and then there's 4 zones. Each zone has its own valve. It's fed with natural gas right here. Um, it's an older furnace. The plate on it says it was manufactured in 1983, so it is original at this house. This house was built in '84. Um, so it's not a high efficiency furnace. The exhaust is very hot and is piped up into the chimney. Um, and there's, obviously a lot of other parts and components to this. Expansion tank here. There's various valves and things like that. But this is an old system that I do want to replace sometime. I'm not quite sure when, but recently I discovered that one of the zones is not producing heat. So I have baseboard radiant heating, and that's the sort of like, those registers that you see go along the walls or beneath windows and things like that. Actually, we'll show a little bit of that. And when the thermostat in one of the zones calls for heat, it has wires that come down to here, and it tells the boiler to flame up, start heating up the water in it. I think there's like a 5-gallon tank inside of this thing. So that'll heat up, and then once that water gets to a certain temperature, it might be 180 degrees, I forget. I mean, those things are all kind of variable. It'll tell the pump to start to circulate, and then one of these valves or more will open up. I mean, you can have all 4 open at the same time. You're obviously going to divide your BTU capability by, that number. But anyways, you can have one or all zones open. They're independent of each other. So the zone that I'm having trouble with right now is this one right here. This feeds the first floor living room of the house. There's 2 zones on the first floor. So this zone operates the other side of the first floor, and these aren't all labeled really great. I think this is the basement. The room I'm in right now. This room is heated. Yeah, I'm pretty sure it's basement. This would be the other half of the first floor. This would be the first floor, part of the first floor that's having trouble, and this is the second floor of the house where the bedrooms are. So all these are functioning fine except for this one right here. So I'll explain how I troubleshot this and what I'm doing to fix it, and maybe some steps to sort of like verify that fix too. All right, so first things first is I used this tool here. This is a gun that just sort of will give you the temperature of whatever you're pointing it at. It is a little laser here. And you can see here that like this block right here is 92.8 Fahrenheit. That's 102. And these are going to be pretty warm because this thing's hot, and these are all copper pipes. What really matters as far as knowing if the heat's circulating through the system is you go into the part of the house where you suspect the heat is or is not working, and you want to point this at your register. If that register is basically room temperature, then it's not receiving any hot water from this boiler. But if it is, and you should be able to feel the heat coming up with your hand, and those registers should probably put off around 100 degrees Fahrenheit in heat. It depends on a lot of factors, and there is a kind of a warm up and a cool down to that too. But the point is there should be heat that you can feel and notice, kind of like with your hand, and it's going to be a lot warmer than the room so it can bring the room, increase the temperature in that room. So anyways, I ran around and tested the registers, and that room in question, which is kind of over the past couple of years been cooler than the rest of the rooms, and I just always thought, well, that's weird. But I suspect now that this zone control has been maybe failing or faltering or sticking or malfunctioning in a matter where that room was getting less and less heat over time. But to the point where yesterday there was no heat in that room. And it's cold here. I mean, I'm in Massachusetts in New England. It is December. So the overnight temperature last night, I think, was 24 degrees, maybe 20 degrees Fahrenheit. So pretty cold, right? So you definitely need your heating system working. All right, so anyways, I noticed a problem. I got my heat thing, verified that there is zero heat coming out of that room. I also verified that the thermostat's calling for heat, because the thermostat was set to, I don't know, I put it up to like 70 degrees Fahrenheit, and it claims on the screen that it was calling for heat. And there's that like click that it makes, when it's making those contacts to send that signal down here, and that was happening. And I put new batteries in it too. This particular thermostat it's not an expensive one. It's one of those cheap $19 ones. I do have Nest thermostats in other parts of the house. In this just that room I don't. But anyways, so one of the problems could have been the thermostat, and it appeared that the thermostat was functioning. So I come down here, and what I noticed is that this zone, when I touched the pipe here, this pipe was pretty cold, right? And the water flow on this, and this particular system goes down. So the water is going to be coming from the room down through this valve into the boiler. It gets heated up, and it goes up this way, and then it goes to the appropriate zone. So each one of these is a closed loop that goes this direction through the system and up out of this pipe over here, right? So this was cold. So let me get a temperature of this right now. Yeah, so this is 92 right now. I did force this zone open to make it work as part of the troubleshooting process, and also to get heat in the room. And how you do that is there's a little valve over here, and I'm going to bring the camera over here and show that in a second. But there's a lever right on each of these that you can force this valve open. So I did that. And also I want to point out, before I even did that, I was touching the heads of these units, and some of these things are hot, like some things are, I don't know, up to 180 degrees, like the boiler is. Like, you wouldn't want to touch these pipes here, so you do have to exercise some caution, and definitely use one of these. And if you got one of those thermal cameras, right, that's great too. I mean, that obviously would show a lot of information. But anyways, the tops of these units should not be hot. And again, I'll bring the camera over in a second. But so I touched, this one, that's cool. This one, that's cool too. This one is kind of burning hot, right? It's very hot, the top of that, and the top of this is cool as well. So regardless if these things are open and closed, the top of that should be cool. And I thought, well, that's interesting. I have the thing that's not working seems to be very hot to the touch. And when I looked that up online, that is sort of like a classic symptom of the unit burning out and failing. So I thought, well, that's okay. So I said, okay, well, that's consistent with, what's happening with that room. So then I operated that lever to open up that room manually. The second I flipped that lever forward, I heard the furnace sort of like, turn up and start pumping water. I went up to that room, and very shortly after that, the registers were, um, you know, showing that the heat was increasing in the room there up to 100 and something degrees. And then, after several hours, the room temperature started to feel warmer, and the thermostat did eventually read the room at 70 degrees. So, which is great, right? So the problem seems to be this valve. But here, let me bring the camera over here, and I'll show like what things I observed from it, how I tested it, how I operated that lever, and also I went to the local hardware store and I bought the replacement part for it, and it's Takeo, right? So this is the top of it. So you don't have to buy the entire thing and like solder a whole new thing in. You could do that. You don't have to. This part, as far as I can tell, is fine. It's this part which is malfunctioning. The cost for this locally here in Massachusetts was $133 plus tax. It's not cheap. Online, yeah, Amazon, with like maybe a week sort of delivery, this I think was $80. So it's cheaper online, but I didn't feel like waiting in the winter with that, or possibly taking longer or whatever. But and if you bought the whole thing, the solder this in, I think that was $200 and something. So anyways, so this is the unit, the replacement piece. This thing just twists onto it, and then there's 3 electrical terminals. This is the lever that I was talking about. So this is the manual override to open that valve, and then this is when it's back into automatic mode, where it should operate electronically through these electrical contacts. And the part that I'm talking about was being hot was right up here on the other side. It's burning hot on this system. It's probably because I assume the system is telling it to open up and move that valve, and it's just stuck, and it's not, and it's just sitting there, just sort of like producing heat from the I don't know, friction or resistance from whatever's malfunctioning inside of that thing. All right, so I'll bring the camera over and show kind of like how I troubleshot that a little bit, how to replace this, and do some more testing. And by the way, the tools that you really need for this is a method of measuring the temperature somehow. This, right, is great for that. Bought this part here today. A screwdriver, Phillips, and a flathead. This is a multi-bit, and I've got my flathead right here too. So, all right, let's move to the back side here, and we'll. Okay, here we have the back side of the system. So the second unit from the bottom of the screen here is the one in question, and that was extremely hot to the touch, and also it is the one that corresponds with the room that was not getting any heat. And I had operated that lever, you could see kind of on the bottom side of it, near the terminals. Yeah, so this is really hot to the touch. The other ones are not as hot, not nearly as hot. And remember that heating up is a classic symptom of that thing failing. All right, so 129 degrees Fahrenheit, so that's pretty hot. And let's see, the bottom one here, 86 degrees, 84, and this one is 83. So definitely a big difference there. Yeah, 127. So pretty hot. That shouldn't be getting that hot. So we're going to replace this unit here. And there's 3 terminals on it, and we're going to replace the 3 wires in the same order that they're coming off from. There's that red wire on the right, the white one in the center, and another red one on the right side. I'm sorry, I mean red on the left, white in the center, and red on the right. And you can see that there's this lever here I have operated into the open position, and and I have the power turned off to the furnace, so it is de-energized. Now this new replacement unit, although it is a different color, it is the same. It is a supported replacement part number for this. The old one is a 555-0. It's either 01 or 02. And the directions and the packaging of this indicate that it is a valid replacement for the 555 series, which is what this is. Everything else about it looks to be the same number of connections. Everything's the same place. The lugs on the bottom that connect it to the valve are the same. So it looks like it's a suitable replacement for this. And there's that valve. I'm just putting that valve lever from the open position to the auto position, which is where it should operate in, and then putting that back into auto too. All right, so all we got to do is replace these wires one at a time, and then switch over to put them on the new terminal, and then connect the new one. And I don't want to mix anything up. I don't know what the schematic is for this, or what the function of each wire is. I really don't need to know that. I just want to replace this and have everything be in the same position. All right, so when you're doing something like this, you don't want to unhook all the wires and then not know where they go. Right? We don't need to reinvent the wheel here. We just got to replace this part and have everything be put back the same way. All right, so the first wire I'm going to do is the left red wire. And this old one has flat screws, which is pretty common for older stuff. The new one is a flat / Phillips style screw. All right, and the wire here, you want to have the sort of like the hook of the wire pointing clockwise. So when you tighten the screw down, it actually tightens and grabs the wire and makes it tighter. If you have the screw hook pointing counterclockwise, then when you tighten the terminal, it can loosen that wire or push it out. Right, so there is a right and a wrong way to attach wires to terminals. The next wire is the red wire. I'm sorry, the white wire in the center. And this is a pass-through wire that just has some of the insulation removed. Right, so there's no hook to that. It's just a pass-through. So we're going to move that to the middle position, and we're going to tighten that up. Yeah, in this situation, there's enough slack here where I am able to, sort of like have the old one installed and the new one wires moved over to it at the same time, which is pretty nice. If I didn't have enough position here or enough space to do this, I could always label the wires somehow, if they all have to be disconnected. Definitely take a picture of stuff right before you move things around, because that helps a lot. All right, so that's the third wire, which is a red on the right side, also a pass-through. And I'm just going to tighten the 3 of these down pretty good, and just firm them up. We don't want it to be sparking or loose or anything like that. And when I say firmly tighten, you don't want to like over tighten it, but usually once I start to meet resistance on turning the screw down, you know, if you go like a eighth to a quarter turn more, it usually does it. So this old head unit here should just rotate off of this. And there we go. That's the old one. And the new one will just go into those same lugs and rotate on the same way as the old one came off. Okay, and let's give it a firm turn. There it goes. And now that seems to be fully installed. Attached to the valve. Wiring is installed. Valve is in the lever's in the auto position. So I'm going to turn power on to the furnace now. So that'll energize this wiring. And it'll take a couple minutes for the thing to sort of like turn up before it starts, you know, opening valves or doing anything. But we're going to go upstairs and test the register to see if the registers are producing any heat for that room in the auto position. And that'll be sort of like the test of that valve. Also, if it remains cool, when I'm going to have to, for the next couple of days, keep on touching this thing, measuring the temperature to make sure that it's not getting too hot. I assume it'll be the same temperature as the other ones, about 85 degrees or so. And yeah, I'll leave that lever in the auto position, which they're all in right now. And that's about it. And so this unit here, interestingly, they're made in Cranston, Rhode Island, which is about a half hour from me, as I live in Massachusetts. So that's kind of a fun fact. And yeah, I was looking on the inside of this thing here. What's this? There's a nail inside of here? That's odd. I find that really concerning that there was just a nail floating inside of this. I don't know what that's doing in there. I wonder if that had something to do with the failure of this, although I've lived here for 10 years, and I just have no idea why there would be a nail inside of that. It's kind of crazy. But anyways, I can hear the furnace starting up. The pump is circulating. The boiler is heating up water, so things are happening, which is always good. And I'm going to show you the side of the furnace where that switch is. So that switch right here, it's just a standard 120 volt AC power switch, like you would have like a light switch for a room. And you know, that powers this furnace. And side note, this is a pressure relief valve made by Watts regulators, and it's set to 30 psi, and it's just a valve that prevents the furnace boiler from over pressurizing. Without this, you know, the system could, you know, if it had a runaway problem, like let's say the flame just stayed on the whole time, the thing could explode if it, you know, got too pressurized. And this thing here burps or relieves the air from the system. So yeah, you don't want to have air inside of the system. If there's air, it causes two problems. It reduces the efficiency of the system because air doesn't conduct heat that well, and also it's noisy too. You would hear like the bubbles kind of like moving throughout the pipes. And there's another one of these up on the top. So you have like kind of like on the low side and the high side of the system, and above the pressure relief tank. Okay, so here we are in the room where the heat wasn't working, and we're checking the register out, and it's registering 119. Yeah, okay, 129. That's great. Yeah, that seems to be about the right temperature for a register. And that's it. Let's keep an eye on this.
Hi, Megan here.